Hi, good day, all of you. Let us start the introduction part to microprocessor and microcontroller lab. Before I start, I would like to know that is my voice audible to you, all of you? Just message me in the group that my voice is audible so that we can start. That's great. Okay, so this is a microprocessor and microcontroller lab in which you have two directions. Okay. First direction is, and the main direction is a microprocessor part, where you will be learning assembly language programming. And the other part is microcontroller lab, where you will be learning about Arduino. Okay. Now, for Arduino, you have two ways to do. Either you need to have a hardware and a software called Arduino that should be installed, and we can do experiments on that. But because for the last lab also, we have done this on the internet. So we need an internet connection for doing Arduino programming, so that we'll do on the virtual boards. But for microprocessor lab, this is programming in assembly language. So here we will be seeing all the programs in assembly language, and we'll see how to execute these programs. Okay. So there are the two direction. One is microprocessor part and another is microcontroller part. Okay, and for each of them, you will be having lab reports which you are supposed to submit. So before I begin, I would like to share my screen so that you can see it in a clear manner. So all of you, do you able to see my screen? Hope my screen is visible to you, and also the voice is audible. Yeah. Okay. Now, see here, this is our lab manual. You can see this lab manual in your Blackboard. Okay. Here you will be having the lab reports, and the lab manual will be attached for both the microprocessor. This is microprocessor part, and this is the lab reports for Arduino experiments. Okay. And you can submit these lab reports online through the Blackboard or in person. Let us discuss that the polling session that we'll take. We'll find out with all of us what is convenient to you. I think it's better to hand over the lab reports by hand so that you can easily understand it. So this will be our first lab experiment. Here I'll show you. Yeah, this is your lab manual. So you'll be having the first assembly language programming, objective tools, everything is discussed here, experiment 2, 3, and 4. This is the microprocessor part. And remaining two experiments will be from the Arduino part. Sorry. So the first program is about the assembly language program. Okay. So in this assembly language program, our objective is to understand how the tools like MASM, linker, okay, editor and assembler, loader and debuggers are used. We'll see today in this experiment. Okay, and this lab manual will be updated in the Blackboard, uploaded in the Blackboard. You can have a look, and you can keep this for your reference and for your understanding. Okay. Now, there are different levels of programming. in microprocessor and microcontroller lab, we are learning assembly language. Okay, do you see this second option? This is the assembly language. Actually, there are three levels of programming. One is called high level language, okay, which is like English like language. You might have already completed a course on C++, right? C++ is a high level language. Now, this high level language is closer to the user and far from the hardware. Then, when it comes to assembly level language, it is closer to the hardware. Okay. So assembly language are nothing but the instructions which are having mnemonics. Okay, like in high level language you have symbols for adding, plus, minus. Okay, but here in assembly language for adding you have a mnemonic called add. For subtracting you have mnemonic called sub, like this. Machine level language is the language in which the program is written in on binary zeros and ones, which is understood by the computer. Okay, machine, which is zeros and ones. So computer can understand it and execute directly if the program is written in machine level language. But it is very difficult for us to learn machine level language, because if one zero is replaced with one or vice versa, then it creates a lot of problem. Okay, so that's why we will do in assembly language. We will write our program in assembly language, and we will convert this assembly language program into machine level language with the help of some translating tools. Okay, those translating tools which we will be using is one of the tools, and the tool which we are using for writing this program is another tool. All those tools together, they are called as assembly language program development tools. Okay, so we require these tools for developing our assembly language program. First is we need to write something, the program, right? This program is written with the help of this editor. Okay, the program is written with the help of editor. So I will show you what is editor. Mm, while practically, right? Then using editor you will write a program. When you type a program, this program has to be written in a machine assembly language, right? So when we write this in assembly language, remember, in the previous semester you might have completed C++ programming, that in that we have learned that if a program is written in C, then its extension will be .c. And if the program is written in C++, then its extension will be .cpp. In the same way, if the program is written in assembly language, its extension will be .asm. Okay, .asm. So with the help of this editor, we will write assembly language program. But this assembly language program is not understood by any machine. So we need a translator to convert your assembly language to machine level language. The name of this translator is called assembler. Okay. So the assembler is used to convert your .asm file into .obj file. Okay, .obj file. Now, again, this .obj file is not a complete, it's a binary, but with fill up the blanks. Okay, there are some missing references. To make it complete binary, we need a linker. Okay, it will it will join all the object files .obj file, okay, and produce an exe. This is executable file. So linker will convert obj file into exe file. So I repeat, editor is used to create .asm file. Assembler is used to convert .asm to .obj file, and linker is used to convert .obj into .exe file. Okay, so these 3 points are understood. Do you understand these 3 points? I need your answers. Okay, that's great. So if you have understood this, now today in this session I will just show you Okay, we'll not go into the deeper. Okay, just I will be showing you how to type the program with the help of editor, and how to convert this program into OBJ with the help of assembler, and how to create an exe file machine language with the help of linker and loader. Okay, so let us see all those things now. Now there are before writing an assembly language program is nothing but a set of instructions, correct? Yeah, program is nothing but a set of instructions. Now this set of instructions are nothing but it's a combination of data and instructions working on the data. For example, if you write a program for adding two numbers, okay, then adding two numbers, first number you will store in suppose a variable a, and second number you will store in variable b. And when you want to add both of them, c is equal to a plus b. So c is equal to a plus b is an instruction which is working on data a and b. Okay, and some of them is stored then in c. So c is a, b, c are data, that is variables, and c is equal to a plus b is an instruction. Okay, so whenever you want to write any assembly language program, okay, you need to define where your data will reside and where your program will instruction will reside. Okay, to support that concept, we have different types of models, memory models given in the assembly language. First is called tiny model. In tiny model, program this is actually not used, very rarely used. That all data and code, that data and instructions. Code is nothing but instructions. Okay, so data and instructions or data and code will come in one segment. Finish. That's all. They will come only in one segment. Small means for data you will have one segment, and for code you will have another segment. Okay, so remember this. In tiny, data and code will reside in one segment, and in small, data will be in one segment and code will be in another segment. This is for your information that each segment in assembly language is 64 KB. Okay, 64 kilobytes. Remember this. Now in medium model, it will contain one data segment for storing data, and for code segments you can have multiple code segments. So this is used for larger programs. Okay, in compact, you will have only one code segment. It's x of medium. Okay, but you can have any number of data segments. Okay, now there is another combination called large, in which you can have more number of data segments and more number of code segments. That's all. Okay, so in our programming we'll be using small model, no problem. You can use any one of them according to the requirement of your program and data. Similarly, huge means you will have huge data. Okay, it means the data segment may contain more than 64 kilobytes each, the same as large. But here in large, multiple code segments and data segments, each of them are 64 KB. The segment size is 64 KB, but here the segment size may exceed 64 in huge. Similarly, flat, it's only available in MASM 6.0. The flat model uses one segment of 512 kilobytes only. Okay, to store, here actually it is stored, to store all the data and code. So this is used only in Windows and NT. Okay, so now you will also have different types of registers. Okay, in your assembler. Okay, they are called general purpose registers, segment register, pointers, and flag registers. Now this will be I will show you all these registers in practical in the software, that where are all these registers are. So general purpose registers are nothing but AX, BX, CX, and DX registers. They are used for storing data temporarily. Segment registers are also four. Okay, they are code segment, data segment, stack segment, and extra segment. All these are the segment registers. Then you have pointer and index register, base pointer and stack pointer, source index register, and destination index register. Here, instruction pointer, stack pointer, base pointer, source index register, destination index registers. Okay. Now remember, all of them, all these registers are 16 bits. This also 16 bits. This also 16 bits. Now flag register is one bit, and total there are 16 bit. The difference between these registers is general purpose registers. They are 16 bit, but you can split them into half. Okay, 8 bits also you can access. I'll show you how to do that all. Okay, so at this point of time, you just go through. These are all the flag registers. You see, when you count 0 to 15, there are total 16 bits. But each flag register is of 1 bit only. Okay, 1 bit is the smallest unit, 0 or 1. It can store carry flag, parity, auxiliary, zero flag, sign flag, trap flag, interrupt flag, direction flag, overflow flag. And these are in red color. They are kept for future purpose. Okay, they are kept for future purpose. Okay. Now the meaning of all these flags, slowly we will learn in the subsequent sessions of this lab. Okay. So don't worry if you have not understood. So now let us understand. This is your first lab report. How you are supposed to write this. Okay. Now here I will be explaining this lab report. You try this at home or in the lab, and you are supposed to submit this lab report. Okay, to me. So make sure that you are understanding everything. Okay. So now this is our experiment one. So how to enter into debug mode of Microsoft Disk operating system. Now for this, you need to have a software called 8086 software. Okay. So this already I have installed, and in your lab also it is already installed. I hope yeah, this is available here. Yeah, 8086 software is already there, and here you will be having all the files available, and you need to have one software called DOSBox. Okay, you need to install this. That's all. So this installation and everything you need not necessarily know. If you want, you can meet me separately. I'll let you know. You can come up with the laptop. I'll explain, because in the lab all the computers are having the softwares already. We have installed them already. Okay, so you have to click on the DOS box. Now these steps are very important. I'm recording this session so that you can watch it again and again, unless you have understood it. Okay. So as I have shown you that we saved the 8086 in C drive. Okay. So when I just click, it will give me a virtual drive Z. So the first step, remember, you need to mount C with C:/8086. This is the first step. Okay. So now drive C is mounted. When once it got mounted, okay, now you can enter into the C drive with the help of this command C:, and you can hit enter. When you hit enter, you see you are having C drive. Now when you just do dir, so you see in my computer there are many programs, but in when you install, you will have only 3 or 4 files. For example, you'll have files like this link masm. Okay, do you remember this link masm and edit? See this edit, this com file. Okay, so all these are actually, these are the program development tools which I have already taught you. Do you remember? As I have told you, there are some program development tools in page number 6. You see editor, okay, assembler and linker. I told you, right? So all these are available here. You see, this is editor, edit. This is linker. Where is the linker? dir linker star.exe. So I'll just do pipelining page wise. Yeah. Now you see, be able to see here link. This is nothing but your linker. This linker is nothing but this link. Okay. And editor is nothing but your EDIT, which I have shown you. Okay. Assembler is nothing but your MASM, Microsoft Assembler. You are having two assemblers, MASM or TASM. Anything you can use. We'll be using for this semester for your course. Let us use MASM. Okay. Yeah. So now using these tools, okay, we will write how to develop a program. Okay, convert this assembly language into obj to exe, and then exe how we will execute them. Let us see. Okay, so now the first question was how to enter into debug mode of Microsoft this operating system. So I just clear this screen. Now you can go into the debug with the help of the command debug. Okay, finish. So the first answer is how to enter into the debug. Type the command debug. Finish. You are in the debug mode. Second, how do you find the list of all available commands? So first go into the debug mode and then give question mark. It will give you list of all the commands which are available in the machine. This is the second answer. Okay. Third, how to return to the Microsoft Dix operating system? It means how do you come back? Just press Q. Q is for quit. You see here. Q is for quit. It will come back to MS-DOS prompt command line again. Okay. This is the answer 3. Okay. Now fourth question is what is the extension of assembly language program? What is the extension of assembly language program? The extension of assembly language program, as I've already told you, you will write a program with extension .asm. Okay. So write the extension of assembly language program is .asm. Okay. So the next question is if the name of the assembly language program is program1.asm, using MASM and the other tools, show the steps to generate program1.exe. Yeah. So now this is our program. This is our program code segment. So let me arrange them in a proper manner. Yeah. Okay, let it be, no problem. I'll just make big screen. Yeah, all of you are able to see this. Now I will write this program, use the help of editor tool. Okay, and then I will compile this and convert this ASM into obj to exe, and I will show you how to execute it. Okay, so I'll just make it the big screen. Be able to see my big screen, all of you? Yeah. So this is my screen. So now with the help of the program development tools, we'll show you how to write this program. First step, how do you write a program? We can type a program with the help of editor tool. Okay, so as in the question it is given that let's use the name of the program as program1.asm. So I will write edit program program1. Just I will clear the screen. Yeah, here I will write so that you can see it clearly. Edit program program1.asm. Okay, so you see it will open a editor. So this is the place where you are going to write the program, type the program. Okay, as I have told you, program is a combination of data and code, correct? So you need to have two things, data and code. So now here I don't want data. I need only code segment. With the help of only code segment, I'm it is possible to write without data. In the without data segment, I can write the data in the code segment also. Okay, so first I will show you only with the code segment how to write hello world program. Then I will show you how to use code segment and data segment as well. Okay, like in the uh, program models, I have shown you tiny, small, flat, huge, large. Okay, so that the second example I'll show you. Okay, so let us see first how to write an assembly language program. Now you see, all of you observe that the extension of my program is .asm. Okay, so now I write the program underscore code. This is code segment. Whenever you write code segment, then you should also end the code segment. So underscore code end means end, but this is, you should not write. This is you are ending a segment. So write s, and s means ending a segment. So understood, this code underscore code segment means code segment is starting. Underscore code ends means code segment is ending. In between this, you have to write your code part. Okay. So here I am writing the coding part. So the assume, okay. CS is what? Code segment register. Now you just see. I will explain all of you, that what is CS, what is DS, okay, what is move, everything. Don't worry. But in this lab, the goal is how to use editor tool to write a program, compile it, execute it, see the result. That's all. This is our goal. And slowly we will be learning the meaning of these instructions, okay, throughout this semester. Okay. So assume CS is equal to underscore code, okay, and ds underscore code. So I'm using code segment also as code, data segment also as code. Okay, so it means I'm writing my code and data both in code segment. Okay, yeah. Then after this, okay, after this I'm writing start. Okay, jmptem skip. I think I got some message from one of the students. Let me check what is that. Yes, underscore is uh, if we are using underscore, we have to use underscore everywhere, right? It's important, and say macro like that. If you are using underscore, then we have to use everywhere underscore. But if I don't use underscore, everywhere code segment should come without underscore. Okay, so I have written underscore code. I didn't get your answer. Do we need the underscore? Yeah, this is the conventional type of programming where we write for code segment, all the segments which are specific to our programming model, we will write with underscore. Okay, and this is not mandatory. Without underscore also you can write. Okay, no, we have to use it. We are using it. You see, when you write here underscore code, you are using it here in the code segment and in the data segment. Okay, yeah. I hope I have answered your question. Okay, so shall I proceed? Okay, thank you. Mm. So I'm just typing the program which I have already shared with you. I'll be uploading this lab manual in the Blackboard. Okay. So start, jump, skip. Now you here I'm giving my data. Data is MSG. Message is a variable. DB is defined byte, integer in short in C language. Okay, and or char like that. Okay, so here I am giving a single quote. This is top in your keyboard. Okay, so hello world, hello world. Just I have given this and close. And remember that whenever you are giving a string, you must terminate it with this terminating character. Dollar is to say that my string is finished here. Otherwise, it will go and then display all the characters after word also. Okay, so I'm stopping with the help of this dollar. Okay, so now, okay, after this, I just write. See, we are starting start jump to skip means I'm directly jumping to skip. What is skip? Skip is a label. So skip, sorry, s skip skip, and I have given two colon. It is nothing but it's a label. So jump skip will directly jump to this statement. Okay, it will. This is a data part which I have declared. Okay, and directly we are jumping to skip. So in skip here I will be mentioning the instructions for displaying hello world. Okay, if you want to display hello world, okay, so I have to first move the code segment in AX register. Okay, and then I have to move. Actually, my goal is to move code segment in data segment. Okay, because in data segment I'm having this hello world, but I cannot move code segment to data segment directly because move doesn't allow segment to segment movement. Okay, that's why we take the help of general purpose register, from where first we will move from CS to AX and from AX to DS. Okay, so move. So understood? You see, actually my goal is to move CS into DS, but directly I cannot move because segment register to segment register move doesn't work. Okay, so that's why we are using this general purpose register AX. Okay, so I'm moving CS to AX and then from AX to DS. Okay, data segment. Now after this, in order to print a hello world message, okay, I will use I will use a interrupt routine, which is for that I need to load 09 in AH register. Okay, so move AH comma 09H. What is H? H is nothing but hexadecimal. Okay, and then after this you have to write move, okay, dx comma offset msg. Now this message I'm moving in dx register. Okay, then I'm calling DOS interrupt 21H. Okay, then after this what should I do? The last instructions which is there in every program, move AH comma 4CH and move AL comma 00H. Okay, it means 4C00H when you move into AX register and call DOS interrupt 21H. Okay, it will terminate the program normally. Okay, so this is for terminating the program. Okay, and this is for displaying the message. That's all. For displaying a message, okay, for displaying a message, we need to just move this code segment to data segment with the help of AX register. Okay, now we have finished it. Now you see the code segment is starting here. Oh, that's what happened. It has split into multiple. Don't worry, it got split into two windows. Both are same, don't worry. So we will change it with view, split window, close window. Yeah. So your code segment is starting and you're ending. But you see here, we need to also, there are two labels, skip and start. So we should end the start symbol also. Start is like main from your in your C program. So how do you end start? So end start. That's all. Write end and write the name of the label. This is for ending labels. For ending segments, you will write S, name of the segment, and at last you will write S. Okay. So now this is my program called program1.asm. So go to file, save it, then go to file and exit it. After exiting, now you see when I say dir program1, now you see I got program1.asm. Okay. So how do you convert this program1.asm? How do you create this program1.asm? With the help of editor tool, correct? EDAT. Now I want to convert this program1.asm into obj file. For this we need another tool called masm. Okay, assembler. So assembler is used to convert a machine language to a to assembly language to machine language. Okay, so for that I'm using another tool called masm. So masm, remember masm. Okay, option L. Name of the program is program1.asm. Okay, so the input to masm is .sm and output will be .obj. Now you see it is creating the obj file, correct? Program1.obj. Finish. And it is also creating a .lst file, crf files. Finish. So Alhamdulillah, with successfully we have created an obj file with no errors and no warnings. So this is a very good thing. But remember, when you type the program in the lab, you might be getting some errors. If you get any errors, you cannot go to the next step. You need to first rectify all the errors and then come back here. Okay. So that's great. So now you see earlier, do you observe you are having only program1.asm, but now you are having what? Program1.asm and .lst and .obj file also. So we have successfully created obj file. That's great. Now after we create an obj file, now how do we convert this obj into exe? For this we have another tool. Do you remember? That is called linker tool. So let us take the help of link to get an exe file. Okay, so I write link. This is another tool. So the input to this tool is what? Program1.obj. Okay, and it will give me output exe. Now see here. Do you see program1.exe? It is giving me the output as exe file and .map file .lib. Finish. Okay, so it has given one error that no, it's a warning. We can ignore this. Okay, so no stack segment. Ignore it. Warning is like you can ignore them. If there is error, it will not execute. So let us see whether we have successfully created an exe file or not. For this, again, I will write this command. Alhamdulillah, you see that we have an exe file also here. Okay, so program1.exe. Now, how to execute this? To execute this, we can use, for executing this program, we can use loader. But how do, there is no loader program. You just type the name of the exe file, finish. Loader will automatically invoke by the operating system and will give you the output. You see, program1.exe, finish. Now you see hello world, it is executing the program. So successfully we have created a program, first program on hello world. Okay, so with this we have finished first part of your lab. Now we can, once you have created an exe file, we can debug this file. This file will become eligible for debug. So I write debug program1.exe, correct? Got it? Now you see As do you remember, I discussed that there are general purpose registers, four general purpose registers: AX, BX, CX, DX, and pointer registers like base pointer, stack pointer. All those registers you can see here now by typing command R. See, when you type a command R, you see X, BX, CX, DX. All these are the general purpose register. SP, BP, they are source pointer, base pointer, stack pointer, and base pointer. SIDI is source index register, destination index register. Now you see DS, ES, SS, CS. These are the four segment register: data segment register, extra segment register, stack segment register, code segment register. IP is nothing but instruction pointer, which will point to the next instruction. And on the right hand side, you have also seen NV, UP, EA, PL, NZ, NA, PO, NC. Do you see that? They are, count how many of them? They are 8. They are all called flag registers. So in detail, in experiment 2, I will be discussing about this flag registers. Okay. So at this point of time, you see, we have seen all the registers. What I have shown you theoretically in the lab manual, we have seen in the practical, okay, all those registers, okay, general purpose registers, segment registers, index and pointer registers, and flag registers. Okay. So now, if I want to see that my program is successfully terminated or not, so I will just type this, sorry, command G. See, G means hello world. You see, it is giving the output of our program1.exe file. Okay, and it is giving program terminated normally. Why program is terminated normally? Because we have written the last three lines. Remember, move AH 4CH and move AL 00H. Like in AX register, we moved these values, like this one. Mm, where is what is the code segment? 0768. Yeah, this is the program. Okay, so here you will have all the program. Okay, or just I just quit it. You can type your program1.asm. Okay, see the last lines. Do you see? Move AH 4CH, move AL00H in 21H. Because of that, your program has terminated successfully. Okay, so now, Alhamdulillah, we have finished the first part. Now I'll just show you. Let's go to our manual. Yeah, okay. So now here you see, if the name of the assembly language program is program1.asm, using MASM and the other tools, show the steps to generate program1.exe. All those four steps, like from edit till hello world, all that you have to write steps here. Okay, write them all. Now, second thing is, write an assembly language program using macros. No, using macros, I will display the same as a hello world or 8086 lab like this. Okay. So now I have given the program this time. So type this program in your computer, and again use the same steps what we have done above to get the output. Okay, to get the output. So just I'll be showing you in a faster way. So edit program3.asm. So already have typed this. You see model is small. I'm using stall model. Remember last time it was giving there is no stack segment, the warning. Why it was giving the warning? Because we are missing this stack. So now I have written this time dot stack. Okay. Now using macros, I'm printing the same message. So in examination, I may write, okay, write a program to print a message. For example, hello, how are you? Or welcome to the lab, or hello world. Any message I will give you using macros or without using macros. Okay, without using macro means previous example. Using macro means you have to write this example. What is macro? I'm creating a macro. Okay, the name of this macro is called MSG. Okay, okay. So now No, the name of the macro is called printS. Okay, name of the macro is printS. It is printing some message. Okay, so what is that message? The same thing what we have done, that moving ah into 09, and you are moving dx in the offset message and calling interrupt. See here, end m you have written. What is m means? Ending macro, remember. Now here we have data segment and code segment. Do you see here? See, underscore data segment. In data segment you are having message 1 db8086 lab. Okay, and underscore data ends. So when data segment started, data segment should end. When code segment started, code segment should end. End s means ending segment. End m means ending macro. Only end means ending label. Okay, so now you see here, same as previously, we have written underscore code segment. Assume cs is code segment, ds is data segment, correct? So here I want to move this data segment in DS. Okay, so I cannot do directly because segment to segment doesn't happen. So I write move ax comma underscore data, move ds comma x. Then see, printS is the name of the macro. You see, just now I created printS here. This macro. What this macro is doing, it is printing all the message, correct? So what is message one? 8086 lab. This is printing 8086 lab, and this is for normal termination of the program. Okay, and your code ends here, you are ending the label. So you file, save it. Okay, file, exit. p3.asm is the name of the program. So I will use masm option L for p3.asm to get an exe file, correct? Sorry, obj file. You see it is getting me an obj file. That's great. So no errors and no warnings. Then I will convert this .obj file to .exe file with the help of link p3.obj. So it is creating an exe file. So alhamdulillah, it has created. Now you can check. Okay, p3 star, it will give me, you see, .asm, .exe, .obj, all files are there. How can you execute them? Very simple. p3.exe is giving you 8086 map. Finish. Okay. Now when exe is generated, it has become eligible for debug. Okay. So p3.exe, I can see the contents of register. And how do you know that the program is terminated normally? Type G. Okay, 8086 lab program is terminated normally. Quit, come back. Okay, and you can exit this screen by typing exit. Finish. Okay, so when you exit it, the program gets ended, terminated. Okay, so now here also what you have to do is, okay, write assembly language program. You have to write the assembly language program, all this, and write all the steps what I have shown in the session. Okay, understood? By this we have completed our first lab activity. So I have recorded this session. I think you need to look thrice or four times to get the concept. And don't worry, this is not a difficult lab. What I have taught you today, the steps will be used in every lab. All these steps will be using in every lab. Okay. So that's why I have recorded, so that you can watch them again and again, unless you have understood it and become perfect in that. And if you want this software to be installed in your laptop, meet me in my office. Inshallah, I'll help you to get it downloaded. Come with an internet connection also. Okay. So if you have any questions, please let me know. Any questions? Okay. So I will be uploading the experiment one in the Blackboard. So watch this video and then make sure that you write the lab. Okay. Correctly. Okay, that's great. Thank you. So I'll stop the session here. See you in the next lab. Thank you. Have a nice day. Assalamu alaikum. Inshallah.